I'm Zhuoling Wang from Iwate University. My research topic is actin denaturation in silver carp myofibrils affected by the stability of myosin bond. Silver carp is widely cultured in China because of the low cost for agriculture. However, it contains an unpleasant odor coming from diet of meroplankton. These are favorable to utilize silver carp as a species for shrimp production. For this purpose, understanding the properties of muscle proteins, especially myosin and actin, which play an important role on gel-forming procedure, is necessary. It was reported that myosin thermostability depends on environment temperature in which they live. Thermostability of silver carp myosin in summer is 30 times stable than winter one, according to calcium ATPase inactivation rate. But there was no information on actin of seasonal change stability. To detect actin denaturation in myofibril, we choose the method of chemotropic digestion. The experiment results suggested actin denaturation could be detected by 1/200th chemotropic digestion at 20 degrees, while myosin was digested by 1/500th. Both could be analyzed as a primary reaction. The slope of line is the denaturation rate. Silver carp myofibril was heated under different temperature and times to detect actin denaturation. We also studied the case that when actin was detached from myosin in the aid of magnesium pyrophosphate. To identify effect of myosin bond furtherly, myofibril was heated advanced to make calcium ATPase inactive sample and S1 removed sample, then do the same experiment as before. These SDS page patterns were myofibril dissolved in 0.1 molar sodium chloride, pH 7.5 when heated from 25 to 55 degrees. Same denaturation extent could be found at 43 degrees for winter and 47 degrees for summer. We measured the decrease in the staining intensity of actin bands. The graph was on the right. There were about 5 degrees difference between summer and winter actin. Summer actin was much more stable. Then myofibril were heated on 42, 45, and 48 degrees to study the denaturation rate of actin. The results showed summer actin was 7.9, 4, and 3 times stable than winter one. Besides, the denaturation rate became quickly with the rise of heating temperature. The erroneous plot of actin and myosin was be summarized. The results showed thermostability of actin was higher than myosin. Both actin and myosin in summer was stable than winter ones. To find out the effect of myosin bond on actin thermostability, 2 mmol magnesium pyrophosphate was be added to myofibril, which can detach actin from myosin, then heated under several temperatures for 30 minutes as before. The temperature of 50% denatured actin became lower than the one without pyrophosphate, and there was no difference between two seasons. Compared the denaturation rate on 42 degrees also get the same result. In the aid of pyrophosphate, the rate was 10 and 4.5-fold faster than the one binding with myosin. Myofibril was heated advanced at 43 degrees for summer and 35 degrees for winter to make calcium ATPase inactive myofibril, and then heated it again at 48 degrees for summer and 45 degrees for winter in the presence or absence of magnesium pyrophosphate. Result graph of winter was showed on the left and summer was on the right. Actin denaturation rate in calcium ATPase active or inactive myofibril had no difference. Additionally, the aid of pyrophosphate in calcium ATPase inactive myofibril didn't promote the denaturation rate of actin, which means pyrophosphate couldn't detach actin from denatured myosin. Thus, it still showed the protection effect on actin. Because the formal experiment demonstrated that calcium ATP as inactive myosin still bound with actin exactly on myosin S1 portion, therefore we used chemotropsin to digest the denatured S1 portion into small peptide. Through centrifuge and dialysis, we removed calcium ATP as inactive myosin bound from actin. This was the SDS page result. There was no myosin heavy chain in winter-digested myofibrils. Then we heated winter-digested myofibril on 45 degrees in the absence or presence of pyrophosphate. Result was shown on the right. Actin became obviously unstable after the removal of denatured myosin bond, but the aid of pyrophosphate didn't promote the denaturation rate. Because summer myosin has the higher thermostability, to determine the effect of myosin bond furtherly, we added summer myosin into winter-digested myofibril. This was the SDS page result. We heated the formal myofibril on 45 degrees for several times. Compared the thermostability with winter-digested myofibril, it could find that actin became stable in the sample added with summer myosin. Therefore, we could make a conclusion that first, summer silver cup actin was more stable than winter one when binding to myosin in 0.1 mole sodium chloride. Second, actin denaturation became quickly after detached from myosin. In that case, summer and winter actin showed the same stability. Second, myosin binding stabilized actin. Fourth, myosin stability affects actin stability. Thank you very much.